All right, so in this lecture, we are going to look at the practical activity 6.3 is still acid-base titration. However, this is between a monoprotic acid, which is hydrochloric acid, and sodium hydroxide, an alkaline, also a base. All right, so the question here, the first question we have here is this. It says you should write the formula of hydrochloric acid. Of course, the formula of hydrochloric acid is HCl, capital letter C. Okay, let me write it well. This is the formula of hydrochloric acid. Very easy. Now, the next one says, write a balanced equation to represent the neutralization. The balanced equation is between HNO3 aqueous plus sodium hydroxide is pouring here, so it will be a little bit noisy. Aqueous, and then this will give us sodium nitrate aqueous plus then we have H2O liquid. Is that okay? That is what we are going to have. So this is the balanced equation for the reaction. The ratio of acid to base is 1:1. Is that understood? Exactly. So the next one now is this. The question says write a balanced equation. Okay, we've done that. The next thing is to calculate the average volume of base used. So we say average volume of sodium hydroxide. Now, like I said, you don't take the rough. You take only the first titer and the second titer. This is the initial bioelectricity, this is the final. Subtract final from initial, you get the volume used, which is in this case 8.50. Then 25 minus 16, that will give us 8.2. To get the average, add both of them, 8.50 plus 8.20 divide by 2. When these two add together, it's going to give us 16.70 mil divided by 2. When this divide this, it's going to give us 8.35 milliliter. All right, that will give us that. Now the next question says record the volume of base used. The volume of base used is 25 milliliter as given. All right. Okay, this is supposed to be record the volume of acid used, not base. All right, record the volume of acid used. Volume of acid used is are you sure we didn't make a mistake here? Let me do a little correction. I think volume of sodium hydroxide, yes. The volume of acid used is 25 mil. Now the next one is record the molarity of the base used. The molarity of the base used is 0.2 molar. So this place they put record the volume of base used. Please change it to what? Acid. Now the next question says calculate the molarity of HCl solution. Now to calculate the molarity of HCl solution, you need to write the formula. The formula is this: CaVa all over CbVb is equals to Na over Nb, my dear student. Now looking at this question very well, our Ca, the concentration of the acid is what we are looking for, which is HCl. So Ca is unknown. Va, the volume of acid used is 25 mil. Cb, concentration of base, we are given as 0.2 molar. Concentration of base was given as what I just said, 0.2 molar. The volume of base, Vb, was given as, what was the volume, the average volume you used for your titration, the volume you calculated. Is that okay? That is 8.35. So this volume of base will be 8.35 mil. Is that understood? 8.35 mil. Then which other thing again? Na. From the balance equation, you can see that the ratio of acid to base is 1:1. So Na is 1, Nb is 1. So we have Na as 1 and Nb equals to 1. Is that okay? So substituting into this equation, what are you going to have? We are looking for Ca. So Ca times Va is 25. Cb 0.2 molar times Vb is calculated as 8.35. Na is 1. Nb is 1. When you cross multiply, this is going to give us 25 Ca, because anything times 1 is still that same thing. 0.2 times 8.35. So divide both sides by 25. When 25 cancels 25, Ca will be 0.2 times 8.35 divided by 22. Let me get my calculator, I'm coming. Now, when you press your calculator, what do you think your Ca will be? 0.2 times 8.35 divided 8.35, which will give us 1.67. So 1.67 divided by 25. My dear student, this gives us 0.0668. Here is what? Molar. That is our Ca, molar, 0.0668 molar. Is that understood? Exactly. So that will be the answer to our Ca. Now the next question is, we have a question. It says calculate the volume of concentrated H2SO4 required to prepare 1 dm cube of approximately 0.05 mol per dm cube. Now, what formula are we going to use in this case? Can you still remember your formula for what is it called? Your formula for dilution formula in your secondary school, where they say C1V1 is equals to what? C2V2. Can you still remember that formula? Exactly. So that one now is what we are going to use in this case. C1V1 is equals to C2V2. However, the specific gravity was given. This Hg means specific gravity. So you can say specific gravity, Hg, is equals to 1.84. Specific gravity is more like density. 1.84. This 1.84 means 1.84 gram per milliliter. Is that okay? So we want to convert this gram per milliliter to gram per liter. To convert to gram per liter, you multiply by 1000, which will give us 1840 gram per liter. All right? So that is that for the specific gravity. Now, what does it mean? It means that in 1 liter of H2SO4, you have 1840 gram. Is that understood? That is the meaning. So 1 liter contains 1840 gram, but the percentage purity was given as 98% pure. 98% means that the entire H2SO4 contains 98% H2SO4. The other things might be impurity. So if you really want to know the amount of H2SO4 in this 1840 gram, we will say it's only 98% of this gram that is in 1 liter. If Adibi will say, okay, the thing is 100% pure, it means this 1840 gram is what is present in 1 liter. But if say is 98% pure, what we are going to do now is to calculate the amount of H2SO4 in gram that is in 1 liter, considering that it's only 98% pure. That means 2% might be impurity. So to do that, you are now going to say that 1 liter will contain normally 1840 gram, right? But because they told you it's 98% pure, you now convert this. So this becomes 98 divided by 100. Is that okay, my dear student? Which will give us 1840 times 98 divided by 100, which gave us 1803.2 gram. Now, what does it mean? This one is telling you that in this 1840 gram that is supposed to be present in 1 liter, are you getting it? That it is only 1803.2 gram of the H2SO4 that is pure. The other about 37% also are impure. Do you get the idea now? So this is because what we are going to use for our titration or for our preparation must be the pure H2SO4. So that's the reason why we calculated this. Is that okay? Now, have we gotten this? This in gram. Now, we want to calculate the molarity of H2SO4. But you know that our molarity, molar mass of H2SO4 is 98. Okay, that is present in 1 liter. So what do you think our molarity will be? Number of moles, my dear student, is equals to mass over molar mass. Now the mass is how many? 1803.2. What is the molar mass of H2SO4? H2SO4 consists of 2 hydrogen, 1 sulfur, 4 oxygen, which is 2 times 1 because, or 1 times 2 rather, let's make it that way. Hydrogen is 1 times 2 of them. Sulfur is 32. Oxygen is 16 times 4 oxygen. 1 times 2 will give us how many? 2 plus 32 plus 16 times 4 will give us what? 64. And when you punch your calculator, I think that will give us 98. 32 plus 64 plus 2. So that gave us 98 gram per mole. That is the molar mass. So our number of moles, my dear student, will be mass is the mass of H2SO4 is 1803.2 gram. Molar mass is 98 gram per mole. All right. Now, at the end of the day, my dear student, what are you going to have? Gram, we cancel gram. So we have 1803.2 divided by 98, which will give us 18.4 gram. So this one, 18.4 mole. Are you getting it now? But because it is in 1 liter, this 18.4 mole is also equal to the concentration. I don't know if, okay. Now, so we have number of moles is equals to 18.4 moles. And our concentration, molarity, is equals to number of moles over volume. Please take note of this calculation because these are the things you are going to go and meet in your exam. So molarity will be number of moles is 18.4 mole. The volume is 1 liter, which of course at the end of the day, this will give us 18.4 mole per liter, which is still the same as what? 18.4 mole per liter is still the same as per dm cube because 1 liter is 1 dm cube. All right. So we are now going to use the formula now, which is this C1 V1 is equals to C2 V2. Now, in this particular question, let's bring out our parameter. They gave to us, calculate the volume of H2SO4. So C1 is unknown. V1, okay, calculate the volume of H2SO4. Our C1 is known. That is the concentration of H2SO4, which we already calculated here to be 18.4 mol per dm cube. V1 is unknown. That's what we are looking for. All right. Required to prepare 1.0 dm cube of approximately. So V2, 1.0 dm cube of approximately 0.05 mol per dm cube. C2, 0.05 mol per dm cube, my dear student. So we can say C1 V1 is C2 V2. All right. Now, calculating using this formula now, our C1 is 18.4. V1 is unknown. C2 is 1. V2 is 0.05. Now, at the end of the day, our V1 will be equal to what? 1 times 0.05 will give us 0.05, all divided by what? 18.4. So our V1 would be equals to, so let's press our calculator, 0.05 divided by 18.4. My dear student, that will give us 0.0027. What is the unit? Unit would be in dm cube. All right, or liter, dm cube. This is in dm cube. So if you want to convert this to milliliter, you multiply by 1000, because dm cube is 1 liter. So if you want to convert to milliliter, you multiply by 1000. So this will give us 2.7 milliliter. All right, that will give us 2.7 milliliter as the correct answer. And that is the answer to that question. Is that understood? Now we have the next question here that says, if A is a solution of nitric acid and B is a solution of sodium hydroxide containing 4 gram per dm cube of solution. Now, 25 centimeter cube portion of B required an average of 24 centimeter cube of solution A for complete neutralization. Calculate the concentration of B limol per dm cube. Now, first of all, let us take the values for B. B is a solution containing sodium hydroxide. Now, let us calculate the molecular mass of sodium hydroxide. Sodium is 23. Oxygen is 1. Oxygen is 16. Hydrogen is 1. 16 plus 1 is 17 plus 23 will give us what? 40 gram per mole. That is the molecular mass of sodium hydroxide. Is that okay? Exactly. So that is that. Now, the question says calculate the concentration of B in mole per dm cube. Now, the concentration of sodium hydroxide in gram per dm cube was given as 4.0 gram per dm cube. Now, my dear students, write this formula out. Very important. Concentration in mole per dm cube is equals to, all right, it is equals to the concentration in gram per dm cube divided by the molar mass. Take note of this formula. Divided by what, my dear student? The molar mass. So in this case, What is our concentration in gram per dm cube? Is 4. So we can say our concentration in mole per dm cube will be equals to 4 gram per dm cube divided by 40 gram per mole. When gram cancels gram, 4 divided by 40 will give us 0.1 mole per dm cube. So my dear student, the concentration in mole per dm cube for B is 0.1 mole per dm cube. Is that okay? Now the next one is the concentration of A in mole per dm cube. Now the balance equation for this is sodium hydroxide and HNO3. So let us balance the equation. You have HNO3 plus sodium hydroxide, which will give us what? If you balance this equation, you're going to give us sodium nitrate aqueous plus water aqueous. All right? HNO3 aqueous, sodium hydroxide aqueous, and so on and so forth, my dear students. Now, the ratio Na, ratio of acid to base, is 1:1 from the balanced equation. So our Na is 1, our Nb is also 1. All right? Now, what is the concentration of the base? Is what we calculated, 0.1. So Cb, 0.1 molar or mole per dm cube. If I write molar, since it's as mole per dm cube, is that okay? Now, this mole per dm cube is still same as if I write capital letter N, molar. Now, that is that. The next thing is, what we are looking for is the concentration of A in mole per dm cube. So concentration of A, Ca, is unknown. What about Va? They were given the volume. 25 portion of B required an average so of 24 centimeter of A. So Va 24.0 centimeter cube, VB 25.0 centimeter cube. So my dear students, formula is Ca Va all over Cb Vb is equals to Na all over Nb. Is that okay? So our Ca in this question, that's what we are looking for. So we have Ca, Va is 24. Cb is unknown. Cb is 0.1 rather. Vb is 25. That will give us 1 divided by 1. All right? When you cross multiply, this will give us 24 Ca. 0.1 times 25 times 1 will give us what? 2.5. So divide both sides by 24. When this cancels this, our Ca will be 2.5 divided by 24, which gave us 0.1042 mole per dm cube. So that is your concentration of A. Now the next thing is concentration of solution A in gram per dm cube. This one we just calculated is in mole per dm cube. Now concentration of solution A in gram per dm cube is very, very easy. What you need to do is just write concentration of A in gram per dm cube is equals to concentration in mole per dm cube times the molar mass. Now, HNO3, what is the molar mass of HNO3? Hydrogen is 1, nitrogen is 14, oxygen is 16. So we have 16 times 3, which is 48 plus 14 will give us 62. 62 plus 1 will give us 63 gram per mole. All right? So that's the concentration of what? HNO3, 63 gram per mole. Now, I haven't gotten that. So concentration in gram per dm cube for A. What's the concentration in mole per dm cube as you calculated? 0.1042 times 63. All right, which is 63 times 0.1042, which gave us 6.56 gram per dm cube. So this will be your concentration of A in gram per dm cube. Is that okay? Concentration of A in gram per dm cube. That will be your answer to that. Let's see the next one. The next question says, A is a solution containing 3.5 grams of an acid per dm cube. B is a solution of 0.this of 100 this per dm cube. Take the average volume of A used as this and that of the base for complete neutralization. Now, this is the equation of reaction. Say from this, what is, using this information, what is the molar concentration of solution A? Now, look at it. From this question, they gave in mole per dm cube, right, of solution. Molar concentration, that means in mole per dm cube. Now, I say A is a solution containing 3.5 grams of acid, HS per dm cube. So, it means concentration of A, this is given in gram per dm cube, is 3.5 gram per dm cube. B is a solution of 0. So concentration of B, Cb, 0.05 mole per dm cube. Are you getting it? Take the average volume, Ca, of acid, Va, average volume of acid, Va, is 26.10 centimeter cube. All right? And that of the base, Vb, is 25 centimeter cube for complete neutralization. Now, from the equation, Na, you can see it here. They give you the equation of reaction. Na is 2, Nb is 1. So, it's 2:1. So, Na, Nb is 1, my dear student. Is that okay? So using the formula CAVA, using the formula CAVA all over CBVB is equal to Na over Nb. My dear student, what are you going to have? It's very easy. What is our Ca? I think that is what we are looking for. Because the concentration was given in gram per dm cube. Maybe you know the molar mass, you would have just calculated it straight from here, but you don't know the molar mass because they gave you HS. You don't know what is X yet. So Ca is what we are looking for. Va is 26.10. Cb, concentration of the base, 0.05. Times Vb is the volume of base, 25 centimeter. Na is 2. Nb is 1. When you cross multiply, this will give us 26.1 Ca is 2 times 0.05 times 25. So divide both sides by 26.10. Divide both sides by 26.10. This cancel this. Your Ca, if you punch your calculator, is going to give us what? That will give us 2 times 0.05 times 25 divided by 26.10. That gives us 0.0958 mole per dm cube. So this is our Ca. Is that okay? Concentration of the acid in mole per dm cube is 0.095 mole per dm cube. Is that okay? 0.095 mole per dm, 958 mole per dm cube. Now, the next question is molar mass of solution A. Now, you use this formula to get the molar mass, right? Molar mass is equals to the concentration in gram per dm cube. Are you getting it? Then divided by the concentration in mole per dm cube. Is that okay? This is because when dm cube divides dm cube, you are now going to have gram per mole. Is that okay? And what we are looking for is the concentration, the molar mass in gram per mole. Is that okay? So what is the concentration in gram per dm cube as we calculate as was initially given for A? Is 3.5 gram per dm cube. Look at it. For A, this was the concentration given in gram per dm cube. So we come here and say molar mass, concentration in gram per dm cube is 3.5. Concentration in mole per dm cube is what we just calculated, my dear student, which is this 0.0958. So we come here and say 0.0958, which will now give us 3.5 divided by 0.0958, which gives us 36.5 gram per mole. What does this information give to us? It's telling us that the molar mass of the acid, which was given as what? Hx, is 36.5 gram per mole. And that makes sense because Hx normally I speculated that Hs will give us what? HCl. And if you calculate the molar mass of HCl, it will give us exactly 36.5 gram per mole. Is that okay? So that is that for that particular one. Let's see the next question. Now, the next question says, A is a solution containing 6.0 gram per dm cube. B is a solution of 12.0 gram per dm cube of hydrated this. Take the average volume of A used as. So our VA was given as 13.10 centimeter cube. And then VB, that of the carbonate, which is the base, is 25.0 centimeter cube. Na, the molar ratio of the acid is 1, or the molar ratio of the acid to the base is 2:1. So we have Na as 2, Nb as 1. Is that okay? Now, let us calculate the concentration of the acid in mole per dm cube, our Ca. I told you that to calculate concentration in mole per dm cube, it is concentration in gram per dm cube divided by what? Divided by the molar mass. In this case, it was HCl that was given. So we can say Ca in mole per dm cube, my dear student, write it Ca in mole per dm cube is equals to concentration in gram per dm cube divided by the molar mass. Now, in this question, what is the molar mass of HCl? Calculate. HCl, hydrogen is 1, chlorine is 35.5, which we just calculated to be what? 36.5 gram per mole. Is that okay? Now, at the end of the day, my dear student, what are you now going to have? The concentration in gram per dm cube was given. Our Ca in gram per dm cube, look at it. A is a solution containing 6.0 gram per dm cube. So 6.0 gram per dm cube. All right? So at the end of the day, concentration of A in mole per dm cube will be equals to what? Will be equals to 6.0 divided by 36.5. This is gram per dm cube. This is gram per mole. When gram cancels gram. What we'll be left with will be mole per dm cube. All right, not dm cube per mole. If you do the algebra, it's more like gram cancel gram. It's like 1 over dm cube divided by what? 1 over mole. Are you getting it? Now, in mathematics, if you have something like this, we are taught that it's going to be 1 over dm cube times what? Mole over 1. Mole times 1 will give us what? Mole per what? Dm cube. So it's not dm cube over mole if you do the mathematics very well. So this is 6 divided by 36.5, which gave us 0.164 mole per dm cube. Is that okay? So that is the answer for A in mole per dm cube. For CA in mole per dm cube. All right. Now, okay, let's say 1.644 a mole per dm cube. Now that you've gotten that, the next thing we need to get now is the molar concentration of anhydrous sodium carbonate in solution. Now, to get the molar concentration of the anhydrous sodium carbonate solution, we've already written everything here. You use the formula CAVA all over CBVB is equal to NA over NB. Is that all right, my dear students? In this case, our CA is what we just calculated, 0.1644. So we can say 0.1644 times VA. The volume of the acid given is 13.10. So you say 13.10 all divided by CB, the concentration of the base. That is what we are looking for, CB, times the volume of the base is 25 centimeter. So we have 25.0 is equals to NA is 2, NB is 1. So it's 2:1. If you do this calculation, 2 times everything here will give us 50 CB, because 25 times 2 will give us 50 times CB will give us 50 CB. 0.1644 times 13.10 will give us 0.1644 times 13.10 will give us 2.153 or 2.154. Divide both sides by 50. 50 cancels 50. CB will be 2.154 divided by 50, which gave us 0.04307. This is the concentration of the base in mole per dm cube. Concentration of the base in what? In mole per dm cube. Now, let us calculate. The next question is value of X and hence the percentage composition. Now, for us to calculate the value of X, we still have some space here. We need to calculate the molar mass of this anhydrous, is a salt. So, I mean hydrated salt. It's a salt, basically, but it's a base, but it's a salty base. All right, they call them salt. Anything in pellet like this, but it's hydrated, so that's taking up some water crystallization. So we need to know the molecular mass of this. If we know the molecular mass of this, then we should be able to calculate for what? For this X. So how do we calculate the molecular mass? We already know that the concentration in mole per dm cube is this. So we know concentration in mole per dm cube. We also know the concentration in gram per dm cube. So what will you think will be the molar mass? My dear student, molar mass formula, concentration in gram per dm cube divided by concentration in mole per dm cube. So what do you think the molar mass of this will be? Molar mass, my dear student, what is concentration in gram per dm cube? It was given that B is a solution containing 12.0 gram per dm cube. So B 12.0 gram per dm cube. Concentration in mole per dm cube is this sheet you calculated, which is 0.04307. So the molar mass will be equals to, calculate that, that will give us 12.0 divided by 0.04307, approximately 279 gram per mole. That is our molar mass, 279 gram per mole. Now that you're getting the molar mass to be approximately 279 gram per mole, the next thing is to calculate for the value of X. But you know that the compound given to you is sodium, this, X water of what? Crystallization. And you know that the molar mass of this is what? 279 gram per mole. So if the molar mass of this is 279, you know that the molar mass is the sum of the atomic masses of everything that are present there. But what we are looking for is what? Is X. So we don't know the atomic mass. I mean, we don't know the this value for X here, but we know the atomic masses of everything here. So from knowing the atomic masses of everything you have here, you should be able to calculate the value of X. Sodium is 23 times 2. Carbon is 12 plus oxygen is 16 times 3. Plus, because of this multiplication, X is what we are looking for. Bracket, hydrogen is how many? 1 times 2 plus oxygen is what? 16. Everything should give us what? 279. Now, 23 times 2 is 46. Let's add everything there. 46 plus 12 plus 48. That will give us 106 plus this X. Everything here will give us 1 times 2 is 2 plus this is what? 18. Which should be equals to what? 279. So 18 times X will give, if this 106 crosses to this side, what are we going to have now? It's going to give us 18 times X will be equals to 279 minus 106. 18 times X will give us 18X. 279 minus 106. That will give us 173. Then divide by what? 18. Which will give us X. If you divide, this cancel this, my dear student. X will give us what? Will give us 9.6. Because we are talking about water crystallization, it is approximately 10. So it means that our X here, my dear student, is 10. So if our X is 10, what do you think will be the formula for this compound now? It will be Na2CO3. In place of X, put 10 H2O. Now the next thing is the percentage water of crystallization. There's no more space. But the formula for calculating percentage water of crystallization is this. Let me, you can pause and write the previous one. Formula for calculating percentage water of crystallization is this. So percentage of water is equals to the mass of water all over total mass of compound. Times 100%. So the mass of water, you look at this this here, we have 10 molecules of water. So we say 10 times what? H2O will be equals to the total mass of the compound they gave to you, sodium triazocarbonate. The total mass is 270, the hydrated form rather. The total mass is, we calculated earlier, was 279 gram. So total mass will be 279 times 100%. Molecular weight for water is 18. That is, hydrogen is 1 times 2 is 2 plus oxygen 16. That will give us 18. So it's 10 times 18 divided by 279 times 100%. 10 times 18 will give us 180 divided by 279. So 180 divided by 279 That is 64.5 times 100. That will give us 64.5. So this gives us 64.5%. Because you are talking about mass over mass, you say 64% weight by weight. All right. So that is that for this particular one. And I think that is the end of these practicals. Thank you very much for your time. We'll see you in the next one. Have a nice night. Bye-bye.